Namaskar, and we will take today factors affecting rate of reactions. And before that, of course, welcome to Crazy Chemistry, welcome to Chemistry Cure. So, factors affecting rate of reactions means which are the possible factors which affect the rate of a particular reaction. So, we can categorize like this: nature of reactant means the nature of reacting species first of all affect the rate of reactions, whether the reactants are like ionic or covalent types of reactant or mixture of both, or whether the reactants are polar or non-polar, whether what is the reactivity of the reacting species. So, these are the factors which includes in nature of reactants, and these factors affect a lot the rate of reaction of a particular reaction. Okay. Second one is concentration. This is again the most important factor which affect the rate of reaction, and of course we will take rate law and rate constant related to concentration of a reactant. Temperature, pressure, and of course catalyst, these are the factors, another factors which affect the rate of reaction consistently and noticeably. They affect the rate of reaction, and of course we will discuss later all of these factors, how they affect rate of reaction. Like temperature, pressure especially affect gaseous reaction, catalyst can affect because catalytic, non-catalytic reactions. So, we will see how a catalyst affect rate of reaction in later lectures. Radiation, of course, some reactions take place in the presence of sunlight or some specific radiation. So, because they may also affect the activation energy. So, how that happens, that we will a little bit will discuss later, how catalyst and radiation can affect the rate of reactions. Okay. So, the most important is rate law and rate constant, which is related with concentration of reacting species. Okay. So, here what we are discussing, how concentration of reacting species is important in studying rate of a reaction. So, rate law we have seen in so many reactions, or it is experimentally proved that with time, as the time passes, the rate of reaction decreases as the concentration of reacting species also decreases. It means the rate of reactions primarily depends upon concentration of reacting species or concentration of reactants. So, rate law is what? Rate law is a relationship between rate of reaction and concentration of reacting species. Okay. So, how it is defined? Rate law, the representation of rate in terms of concentration of reactant is known as rate law. Okay. And rate equation, either rate law or we can say it rate equation. So, how rate is dependent upon concentration of reacting species, say for a general reaction like A plus B is equal to C plus D. Okay, where the small a, b, c and small d are the stoichiometric coefficient or stoichiometric values in a balanced chemical equation, and capital A, B, C, D are concentration terms for the reacting species A and B and the product C or D. Okay. So, how to express the rate equation or rate law for this reaction? So, that is R is directly proportional to concentration of A raised power x, concentration of A raised power x into concentration of B raised power y. Okay. So, this is what known as rate law. Okay. What it is expressing? This is the relationship between rate of reaction and the concentration of reacting species raised with some specific powers, okay. Or what we can say, R is equal to K, okay, concentration of A raised power X, concentration of B raised power Y. So this is what is known as rate law or rate expression, okay, or rate equation is what we can say. And we know that rate is equal to what? Rate is minus, because we are taking the concentration of a reactant, that is why minus. So minus delta C. C means concentration, okay. C means what? Concentration. You don't understand this C. C means here the concentration. Concentration of what? Reacting species, okay. So minus dC upon dt, okay. This is how we can express rate if we are talking the instantaneous rate of a reaction. Or of course we can say minus delta C upon delta T if we are talking about the R average, okay. So this is what the R, okay, simply we say it R. So what we can write here is minus dC. C again I am reminding you, C is concentration, not this one, this C. dC upon dt is equal to K A raised power X B raised power Y, okay. This is the equation which is called the differential rate equation. Which one? The differential rate equation, okay. So here in this equation, what is important term we can see here is the power of A and B, that is X and Y. These are the power which are telling us that the concentration of A affecting according to this power, this exponent, okay. Because this exponent may be like fractional, this exponent may be 1, this exponent may be equal to the stoichiometric value, this exponent may be 2, 3 or whatever, okay. So A is affecting the rate of reaction as per its own concentration with the raised power X. Likewise B is affecting the rate of reaction, and these X and Y are called order of reaction, okay. The sum of this X and Y is called order of a reaction, okay. So exponent X and Y may or may not be equal to this is stoichiometric values, may or may not be equal to our stoichiometric values, and A and B are experimental values. And another thing is what important for X and Y is these are the experimental value. Means by seeing an equation we cannot determine what will be the value of X and Y, because by doing experiment only we can tell how the concentration of A is affecting rate as per this exponent, okay. Because experimentally only can be determined X and Y. So by seeing an equation we cannot determine X and Y. It means order of reaction is always an experimental value. Thus rate law is the expression in which rate of reaction is given in terms of the reactant, okay, with some specific raised with some specific powers, okay. That is what is called rate law, given in terms of molar concentration of reactant with each term raised to some power which may or may not be equal to the stoichiometric values of reactant in a balanced chemical equation, okay. So that is what is written here. It means what? Say a general reaction, let us take NO plus O2, okay. NO plus O2 is equal to 2NO2, okay, 2NO2. So this is what, okay. This is a reaction, and the rate law for this reaction is, that is R is equal to K concentration of NO raised power 2 concentration of O2 raised power 1. So, this is the rate expression or rate law for this reaction, and in this one what we can see is the stoichiometric value and the order of reaction are, the value of order of reaction are same. Okay. So, this may happen. Another reaction is like this one, CHCl3 reacting with chlorine. Okay. CHCl3 is reacting with the chlorine, and what we are getting is CCl4 plus HCl. This is another reaction. Okay. And the rate expression for this reaction is, that is R is already written, so no need to rewrite again. R is equal to what? K. Okay. Concentration of CHCl3 chloroform raised power 1. Okay. 1. If it is not written means 1. And concentration of Cl2 raised power half. Raised power half. It means what? The concentration of chlorine or the stoichiometric value in the balanced equation is different from the order of reaction. Am I right? Order of reaction with reference to chlorine. Okay. So, that is what we are discussing, that these are the experimental value. X and Y are experimental value and cannot be determined just by seeing the equation. Okay. So, this is what the rate law, and this is the differential rate equation. Okay. Now, say if the concentration of the reacting species A and B is 1, is unity. Okay. Then what? Then see, if the concentration of A and B is 1, then what will be R is equal to, of course, K. If A is equal to B is equal to 1 mole or unity is what we can say. It means what? We can define rate constant from this condition, and that is the rate constant is rate of reaction if the concentration of reacting species is taken as unity. Okay. It means K is what? K is nothing but rate of reaction of which reaction? If the concentration of reactants are taken as a unity. Okay. If the reacting species are taken 1 mole of A and 1 mole of B, then what will be the rate of reaction? That will be equal to K. Am I right? So, the value of K gives an idea about, of course, rate of reaction. More the value of K, more will be the rate of reaction. Am I right? And the value of K is, of course, independent of concentration. Why? Because concentration is already, we have taken 1. Okay, unity. Okay, each reaction has, of course, definite value of K, means different reaction will have a different value for K, and it is, of course, independent of concentration of reacting species. So, we can differentiate even between rate of reaction and rate constant. Rate of reaction, of course, speed at which the reactants are converting into product. Rate of reaction is what? This is the speed of reaction, means the how much fast the reaction is happening, that is what is called rate of reaction. But what is rate constant? This is constant of proportionality in rate law. This is what? The constant of proportionality in the rate law. Am I right? Another thing is the rate of reaction decreases with time. Rate of reaction decreases with the time, but this is again a constant value. Alright, and rate is, we can see, dependent upon concentration of reacting species, but the rate constant is independent of concentration of reacting species, because concentration is taken as a unity. So this is how we can even if I differentiate rate and rate constant, because sometime it is asked you differentiate rate and rate constant. So this is how we can differentiate. Now the final thing is unit of rate constant. Unit of rate constant. Okay, unit of rate constant means how we can express rate constant. See, from this equation, let us see unit of rate constant. So unit of rate constant means if we are taking this equation, okay, then our k will be what? K will be equal to rate upon concentration, rate upon a raised power x, b raised power y. Okay, both are concentration. This is concentration, concentration. Okay, so what we can write, rate we know that mole liter inverse time inverse. We are taking time inverse. Okay, not second, not minute, not hour. We are taking time inverse. So mole, okay, mole liter inverse time inverse. Is it okay? Yes. And another thing is, this is what? This is concentration x plus y. Am I right? Concentration power x, concentration power y. So concentration power x plus y. Is it okay? Now, and this is also, see, this we can also write like concentration time inverse. This can be written as a concentration, because R is equal to what? Mole per liter. Mole per liter means concentration. Concentration time inverse, here concentration, concentration x plus y. Is it okay? Then the concentration we know that mole liter inverse time, now we are taking the SI unit second inverse. Okay, second inverse. And here what is there? Again mole liter inverse, mole liter inverse, okay, and x plus y, let us take n. Let us take n. Is there any problem? X plus y we have taken as n. So this is mole liter inverse, this is also mole liter inverse. So this is mole liter inverse raised power say 1. So mole liter inverse 1 minus n. If we will take it as a numerator, then what we will have is k is equal to what? Mole liter inverse raised power 1, this one minus n, this n will go up, so it will be the minus value, and second inverse, where n is what? Order of reaction. N is what? Order of reaction. So by using this reaction, if the order is given, we can determine what? Unit of rate constant K. Like for zero order reaction, say if the order of reaction is 0, okay. So what will be the case? The n will be 0. Am I right? N will be 0. So the unit will be mole liter inverse second inverse. Mole liter inverse second inverse if the value of n is 0. If the value of n is say 1, okay, then what will be the case? 1 minus 1, it means 0. If the power of anything is 0, that will become 1. Okay, so 1 minus 1 0, so mole per liter becomes 1, so it will diminish. What we will have? Only second inverse. So the unit of rate constant for first order reaction will be second inverse. Okay, and for zero order it is mole liter inverse second inverse, and that is the same unit as the unit of rate of reaction. So the unit of rate constant for zero order reaction and unit of rate are always same. This is also asked in so many examination, which is the order for which the rate and rate constant have same unit. So that is zero order reaction. Likewise, if you are taking n is equal to 2, means the order of reaction, if it is 2, then 1 minus 2, that will be the minus 1 power. Okay, 1 minus 2 means here it will minus 1. So minus 1, then this will change liter mole inverse. Okay, if we will solve it, mole liter inverse raised power minus 1, then it will become liter mole inverse second inverse. So this will be the unit of a second order reaction. Is it okay? So this is how we are using this formula. We can easily calculate the unit of any order of a reaction. A balanced chemical equation does not give any idea about the order of reaction. We already discussed this. Okay, this is very crazy point, that a balanced chemical equation does not give any idea about the order of reaction. Order of reaction is an experimental value. Always remember this. Okay, the reaction taking place in one step is called an elementary reaction. Okay, because if the reaction is elementary reaction, then sometime the order of reaction is equal to the stoichiometry of the reaction. But most of the reactions take place in many steps. Okay, so if they are taking place in many steps, then of course x plus y cannot be determined by seeing the reaction, and that is what is called the mechanism of the reaction. Am I right? If the reaction sequence is there, means there are so many steps in a particular reaction, first step, second step, then intermediate, then final product. Okay, so such type of reactions are called complex reaction. Which reaction? Complex reactions. Okay, so this is how actually we can discuss rate law and rate constant. It's quite a simple thing, and the most important thing here are x and y, and that is what is called order of a reaction. In the next video, this is what we are going to discuss, order of a reaction. Okay, we will discuss zero order reaction, first order reaction in detail, and okay, for zero order and first order reaction. So for now it is sufficient, I think. So keep watching videos, keep watching chemistry, keep watching crazy chemistry, keep watching Chemistry Cure, and support this channel. Of course, if I am able to make you understood, okay, a little bit of chemistry, then please support this channel. Thank you for watching. Have a nice day.